Let's start next. Thermodynamic process, right? You are having every Friday about this in your chemistry. Let's once again see the things in our physics way. Thermodynamic process क्या है? Thermodynamic process is said to occur if a thermodynamic variables of a system undergo change with time, right? One by one, let's know. Number one, give heading. Isochoric process, right? Isochoric process. Student, isochoric process means volume constant. Volume constant. Student, volume constant means no change in volume, right? No change in volume means dV is equal to 0, na? Correct? And you know work done is equal to PdV. Yes or no? So work done will also be equal to 0. Is that clear to all?
Yes.
And you know delta Q is equal to, in today only I said you, NCV delta T. Delta Q is equal to NCV delta T, right? Take delta T. Correct, students? And here that is equal to delta U, because delta Q is equal to first law of thermodynamics delta U plus delta W. Na? Do you remember first law of thermodynamics? Delta Q is equal to change in internal energy plus change in work done. This is first law of thermodynamics, students. If we'll put delta W 0, then delta Q is going to be delta U. Yes or no? Getting all? So from here only we can find CV is equal to how much change in internal energy delta U by N delta T, right? Is that clear? Understood, students?
Yes.
This is for the case of isochoric process. And you know, students, PV is equal to nRT, right? You know, PV is equal to what? nRT, na? Correct?
Yes.
Today only we saw that. So P by T is going to be how much? NR by V. And that is going to be constant. Yes or no? N is constant, 1 mole, particular mole. R volume is constant, no change in volume. So P by T is going to be constant. So in isochoric process, can we write for calculating numericals P1 by T1 is equal to P2 by T2? Can we write? Yes or no? Getting, students? On any PV graph, let any PV graph I am saying, let will say about graphs. Number two, let will be saying about graphs, right? So graphs means slope. Slope means P by T. P by T is going to be NR by V. Let's see that graphically. That means what we want to say. Let's take a graph of, this is pressure, right? And this is volume. Okay, student. Volume is constant. That means the graph will be like this. Na? Let this is 0.1, this is 0.2, correct? At this point, there is some pressure. Let that is P2. At this point, there is some pressure. Let P1. Correct, students? And here at this particular volume is constant. So work done is equal to 0. Getting na? Getting or not, students? So in the same way, if I'll be taking the P and V graph, this is P and this is V. Let the graph is like this, correct? And it is connecting to the, so this is let 0.1, let it is 0.2, it is like this. So here you see pressure is P2. At this point, pressure is P1, correct? And this is not pressure volume. Just 1 minute. This is pressure temperature, right? This is pressure temperature graph. So this is 1 point, this is 2 point, this is P1. And here volume is V1. Sorry, not volume. This is temperature. Keep in mind, this is temperature T1 and this is temperature T2. From this graph, how to find the P by T? Slope will give you us what? NR by V. Getting or not, students? Students got a little idea about isochoric process? All?
Yes.
Okay. Next, let's go to, we'll do questions on that. Okay, let me to explain first. Then number two, right? Isobaric process. Isobaric process. Bar is the unit of pressure, no, students? So isobaric pressure, pressure constant. What is constant? Pressure constant, right? So pressure constant means P is equal to constant. And dW is equal to how much? P dV. So that is equal to PV is equal to NR, students. But it will be NR delta T. Yes or no? PV is equal to NRT. But here temperature is changing na. So that's why PV is equal to PdV is equal to nR delta T. And so what first law of thermodynamics gives? First law of thermodynamics, right? First law of thermodynamics gives delta Q is equal to how much? NCP delta T, right? Constant pressure, na? So that is equal to delta U plus W. Yes or no? And that we can say NCP delta T is equal to delta U. NCP delta T is equal to delta U plus W. But W we got how much? Delta V Q we got how much? NCV delta T plus NR delta T. This is about work done. Okay, students? Change in internal energy is what? NCV delta T. That is NR delta T. Yes or no? From here only you can say Cp is equal to how much? Cv plus R. See here, delta T you cancel from everywhere, right? N you common. Take common. Can you get Cp is equal to Cv plus R now? Getting or not, students, the equation? Students, first law
Yes, sir.
delta Q is equal to delta U plus dW. And delta U is how much here? NCb delta T. And W we found how much? NR delta T. Delta T you cancel from all. N you cancel from all. Will you get Cp is equal to Cv plus R? Yes or no? Then for a given mass of an ideal gas, right? For a given mass of an ideal gas, for a given mass of an ideal gas, students, you can get V by T is equal to how much? As we got NR by P, that is constant. Because PV is equal to nRT, you took P to that side because it is constant. And from here only you can see V1 by T1 is equal to V2 by T2. Correct or not? We can use this relation for isobaric process. Correct? And if we'll go for graphs, because question will get the graphs, at that time this concept will be utilized. If I'll take the graphs, then P by T will be how much? NR by V. Correct. So let's see the two graphs. Let's take one graph. This is pressure, and let's take this one volume. So pressure constant means the graph will be like this, correct? Let this point is 1, this point is 2, and the pressure at this point is, volume at this point is V1, volume at this point is V2. Correct or not? If I'll take here press volume and time, as we are taking in the previous case volume and time, here we'll take volume and time. And this point is 1, this point is 2, correct? So this point is V2. At this point the volume is V2 and here volume is V1, right? Right here volume is V1, correct? V2 and here V1, and temperature is T1, temperature is T2. So the graph will be how much? V by T. V2 minus V1. That is, you can get here P by T is equal to NR by V. Understood, students? And isobaric process, student, is in isobaric process, you know, delta Q is equal to NCP delta T. Because pressure is constant, so the change in internal energy will be utilized in at constant pressure. That heat is at constant pressure, and delta U is equal to how much? NCV delta T. Internal work done will be done in changing the volume, right or not? And you know, students, if I will calculate change in internal energy by change in heat, so that will be how much? You divide both, you will get how much? Cv by Cp, na? And already you know Cp by Cv is a constant, that is gamma, correct? And it will be 1 by gamma. So if in this process 1 by gamma, okay, and fraction of, and if you want to find fraction of total heat, right? Fraction of total heat converted to work, how much heat is converted to work? That means you have to take W by change in internal energy delta Q. That is gamma minus 1 by gamma, that is equal to 1 minus 1 by lambda, correct? Understood, student? If only gamma will be given, can you find how much fraction of the total heat energy is converted to work? Just remember all the formulas. because we are going to apply these formulas in the numericals that we are going to solve. Understood up to this? Isothermal got an idea. Sorry, isochoric got an idea, and isobaric you got an idea. Next we will go to isothermal and adiabatic. Right, students? Okay. Next, let's go to give heading isothermal process. Next, right? Isothermal process. Isothermal process means what is constant, students? Temperature constant, right? Isothermal process means temperature constant. And to perform this process, student, what are the conditions? मतलब ऐसा भी मैंने बताया था आपको शुरुआत में, walls of the system must be conducting, right? Diathermic, I told you, such that heat exchange takes place between the system and its surroundings to keep the temperature of the system constant. Number two, process must be slow, so that internal energy of ideal gas depend only upon the temperature of the gas. So here, number one is the conditions maybe walls right here. Walls of the system must be conducting so that the heat can transfer. Walls of the system must be conducting, number one condition. Number two condition is process must be slow. Why? Because process must be slow. Why? Because internal energy of the ideal gas depends only upon the temperature of the gas. That is, for isothermal process, you know, change in internal energy is equal to zero. Heat is constant, no work done. So that means specific heat will be how much? Infinity. We can see here. And work done by in an isothermal process, right? We can calculate that one. See here. Just remember this one. Work done in an isothermal process. Work done in an isothermal process, students. W is equal to how much? Q. That is equal to nRT log base E V2 by V1. We can derive this one later. There is 2.303 into PV is equal to nRT log base 10 V2 by V1. This can be a formula. Also, we can take also here W is equal to Q. That is nRT log base E pressure by P1 by P2 at constant temperature, everything. 2.303 nRT log base 10 P2 by P1. These two governing equations, right, were done by an isothermal process. We can derive this one. Okay. How this derivation came? Just let me to say this one. How this derivation came? Students, you know, in isothermal process, any isothermal process, work done is equal to PdV, na students, correct? Let the volume be changing from V1 to V2, correct? Getting or not? In the same way, we can get also for pressure. And you know, PV is equal to nRT, na students, correct? Okay, so P is equal to how much? nRT by V, yes or no? So now we can write work done by isothermal process is equal to V1 to V2 limit. In place of P work, what can we write? nRT by V into delta V, na? Yes or no, students? So nRT coming out, integration of V1 to V2 dV by V. Integration of dV by V is ln V, na? 1 by V integration is ln V or not, students? That is limit V1 to V2. Getting or not all? So that is nRT into higher limit ln V2 minus ln V1. Correct? So that is equal to, we got nRT into ln V2 by V1. To convert to log base, ln means log base E, log base 10, we are multiplying the extra thing. So that's why we wrote these two formulas. Getting or not? Do you understand how this formula came? Understood or not, students? Right.
Yes.
So this is the way how the formula came. This is isothermal process. Let's see the graph, right? For a given mass, if I'll be taking, right? We'll see the graph, then we'll go for the adiabatic process. Right, see here. Uh, for any, right? For a given mass, of an ideal gas, PV is equal to nRT, correct? That is equal to constant. So can we write P1 V1 is equal to P2 V2? Can you write or not? And if we're taking a graph between P and V, right? We'll take a graph between P and V. It's not constant, no, no, it's changing. Volume increases, pressure decreases. So see, temperature is constant, correct? At this point, the pressure is P1. And at this point, the pressure is P2. And at this point, the volume is V1. At this point, the volume is V2. Getting the students? So slope will be how much? dP by dV or not? Change in volume by change in pressure by change in volume, correct? And it is decreasing. Na? If volume is increasing, pressure is decreasing. So minus P by V, correct or not?
Yes.
Understood, students? Then at last, let's go to adiabatic process, right? Give heading number 4, adiabatic process. We'll see these 4 processes today. Then we'll see the numericals on this on next class. Adiabatic process. Adiabatic process means heat constant. That means no heat exchange. No heat exchange. So here delta Q is equal to 0. और स्टूडेंट यहाँ पर हीट एक्सचेंज नहीं होगा तो कंडीशंस क्या होगा पहला walls of the system must be insulator, right or not? Walls of the system must be insulator. Getting students? Yes or no? And here process must be very fast. Process must be fast. Correct or not? So that is delta Q is equal to 0. So that's why delta U plus W will be there. So work done is equal to how much, students? Minus delta U, na? Yes or no? So what does this negative sign indicate? What does this negative sign indicate? Negative sign indicates, students, adiabatic expansion leads to cooling. Temperature is decreasing, right? Right. Adiabatic negative sign indicates, right? Adiabatic expansion leads to cooling. Adiabatic expansion leads to cooling, right, of the gas in the adiabatic process. Cooling of the gas in the adiabatic process. Work is performed, right? Work is performed at the expense of internal energy. At the expense of internal energy, because no heat is there, right? No extra heat. Understood, students? So here, that means we can also say NC delta T is equal to 0 because specific heat is 0, right? And in adiabatic process, students, equation for ideal gas, PV to the power gamma is equal to constant. What are the equations? Just write here. In adiabatic process, gas equations, right? In adiabatic process, gas equations. Gas equations are what? PV to the power gamma is equal to constant, right? Number 2, T V to the power gamma minus 1 is equal to constant, right? Then P1 minus gamma into T to the power gamma is equal to constant. Correct? And we can see the various graphs for that. Right? And PVT, first law of thermodynamics, we can apply and we can find out all these formulas, students. We can derive all those formulas also. Let me to say one formula, how we get these equations. Just what formula I'm saying. By first law of thermodynamics, we can derive this one. P to the gamma is equal to how constant. Simple. Let's this first formula will derive, right? Just see here. Students, PV, we want to find PV to the power gamma is equal to constant. It's a derivation, one I am doing. The rest you can see, right? Students, see here. dq is equal to du plus dw, na? Correct? Yes or no? And du is equal to how much? Cv delta t. And dw is equal to how much? P delta v. Yes or no? And for adiabatic process, delta Q is equal to 0. Yes or no? So you can write CV dt plus P dV is equal to 0. And you know PV is equal to RT for 1 mole of gas, nRT. है कि नहीं? And you got this much P dV. So you can write differentiating both sides. Let I want to differentiate both sides. P into dV plus keeping V constant dP is equal to R into dt. Correct or not? I made the derivative both sides. Getting students? Then dt is going to be how much? P dV plus V dP divided by R. Is that clear to all? Yes or no, students? है कि नहीं?
Yes, sir.
And we can put this value of dt over here. Now in this equation, we can put the value of dt. So you can write here CV into P dV plus V dP divided by R plus P dV is equal to 0, na students? Getting or not? Because we got this equation, na? Right? Yes or no? Students, getting or not? So let's take R H LCM and multiply that side. So you'll get CV PdV plus CV VdP plus R will be multiplied here. PR delta V is equal to 0. And here students, CV V delta P plus, take bracket here, CV plus R, right? We can take common here. CV you take common plus R you take common from there. What you will get extra? P delta V in every case now, students. This thing came to this place, right? And here P delta V, here also P delta V. So taking common, you will get this much or not? Getting the students? And Cp V delta P plus Cv plus R is Cp or not? Because Cp minus Cv is equal to R, na? Yes or no, students? Cp minus Cv is equal to R. So in place of Cv plus R is equal to Cp, can we put or not? Getting, students?
Yes, sir.
So let's divide both sides by Cv. Both sides will divide by Cv, right? So how much you'll get here? Okay, right from here after this, dividing, right? Dividing both sides by multiply Cp and Pv. Not Cp, you take Cv multiple, divide. Cv, Pv, right? We get, friends, see here, divide here. Cp and V will be cancelled, so that will be dP by P, na? Plus here Cp by Cv into dV by V, na? Pp cancel, right? Yes or no, student? See the derivation carefully. And here you can see here, we got finally dP by P plus Cp by Cv is gamma, right? Constant. dV by V is equal to 0. Now let's integrate both sides. dP by P plus gamma coming out, dV by V is equal to 0. Yes or no? 0.
Yes.
0 means if I'll integrate this one, then this is going to be constant, correct?
Yes.
So this is log base EP, log base EV, that is equal to C. That means log 2 added. So log base E. So it's one gamma is there, correct? Here gamma is there. So log base EP plus log base E V to the power gamma will be there. Yes or no? Do you remember? Log something multiplied means it will be the power. So you can write here log PV to the power gamma is equal to constant. We want to remove log, so take exponent. PV to the power gamma is equal to E to the power C. And E to the power C is also a constant. So P to the power gamma is a constant. Understood or not, students?
Yes.
Understood, students? Understood or not?
Yes.
And here from let will be taking, from here also we can derive that PV is equal to RT, correct? Now V is equal to how much? RT by P, na, students? Yes or no? And you know the equation PV to the power gamma is equal to constant. Let's put in place of V. In place of V, can you put R to the power P to the gamma is equal to constant? Can you put? See, this is P to the power 1 into RT to the power. Here, if bracket will open, then it will be R to the power gamma, T to the power gamma, P to the power minus gamma, na students? Yes or no? Is equal to K, correct? Yes or no? So this is P1
Yes.
into P to the power minus gamma. So it will be P to the power 1 minus gamma, correct? Into T to the
Yes.
power gamma. That will be equal to K divided by R to the power gamma. That is also another constant, right? This is also constant. So you got the another relation that we wrote, P to the power 1 minus gamma plus T to the power gamma is equal to constant. You got that or not? Correct, students?
Yes.
Yes or no? And from here only you can also see in the same way the another relation, that is PV is equal to RT. You put P is equal to RT by V, correct? And you know PV to the power gamma is equal to how much? Constant, na? Okay, nahi? And in place of P you can put RT by V into V to the power gamma is equal to constant. Yes or no? So that is T into V to the power gamma minus 1, that is equal to K by R. That is also constant. So you also got the relation T into, this is V to the power, V to the power T, V to the power gamma minus 1 is equal to constant. You understood how the three relations came between PV? Understood or not, students?
Yes.
We'll see work done in an adiabatic process, right? And how to solve the numericals on that basis, right? Today we just go through all the processes, four processes, what happened, what is constant, how the derivation takes place, what is the equation, everything just go through once, right?